Hello, everyone. My name is Jim Ippolito. I am the Raton Law Endowed Professor of Soil Health and Soil Fertility at The Ohio State University, and I am the chairperson of this National Academies Study Committee. In my role as chair of this study and as the moderator of today's meeting, I'd like to welcome everyone joining us on the live stream and all who may be watching this recording later. If you joined the first session of this meeting, which was yesterday, then these opening remarks are a repeat, but as a reminder, the task being undertaken by this committee of the National Academies of Sciences, Engineering, and Medicine is to assist the USDA in building a framework for addressing PFAS on agricultural land. The committee's full statement of task can be found on the study's website, which is available at the link under Project to the right of the embedded video. This study is sponsored by the U.S. Department of Agriculture's Natural Resources Conservation Service. I'll also remind everyone that this is an open, on-the-record session. Interested individuals and members of the press have been invited to join as observers. Anyone who would like to submit a written comment or document to the committee is welcome to do so by clicking the provide feedback link on the right side of the study website. You can also subscribe for updates about the study by signing up for the National Academies Board on Agriculture and Natural Resources listserv, also on the right side of the page. Today's webinar is an information gathering session. That is, the committee is in the process of assembling materials that it will examine and discuss in the course of making its findings and conclusions. And therefore, I ask everyone to be mindful of the fact that this committee has made no conclusions and that it would be a mistake for anyone to leave the meeting today thinking otherwise. Comments made by individuals, including members of the committee, should not be interpreted as positions of the committee or of the academies. In addition, the committee members typically ask probing questions in these information gathering sessions that may not be indicative of their personal views. You should be aware that the committee will deliberate thoroughly before writing its draft report. Moreover, once the draft report is written, it must go through a rigorous review by experts who are anonymously or anonymous to the committee, and the committee then must respond to this review with appropriate revisions that adequately satisfy the Academy's Report Review Committee and the National Academy of Sciences president before it is ever considered an official Academy's report. The committee members for the study are listed here, and I invite you to read their bios on the study's webpage. With that said, it is now my pleasure to welcome our guests today from the U.S. Department of Agriculture, Agricultural Research Service. We will first hear from Dr. Sarah Lupton. Dr. Lupton has been a research chemist with the Food Animal Metabolism Research Unit at ARS's Edward T. Schaefer Agricultural Research Center in Fargo, North Dakota since 2010. Her research includes the fate of animal drugs and environmental contaminants in lab and food animals, and investigation of environmental contaminant sources such as feed, water, and housing that contribute to chemical residue levels in food animals. Sarah has conducted research on bioavailability, accumulation, distribution, excretion, and mitigation of PFAS compounds in food animals for more than 10 years. Dr. Lupton, thank you for joining us. The floor is yours.
There we go. Thank you, Dr. Ippolito. I appreciate the introduction. So today I'm going to be talking about PFAS fate in agricultural systems and developing data that's useful for informing conservation policy. So just a short overview. With this presentation, I want to answer 3 questions. Why are PFAS data necessary to collect? What PFAS data are necessary to collect? And who uses the data that is collected and how do they use it? This is going to be a broad overview. I'm not going to present any specific data for one area topic, but I just wanted to get kind of a broad overview of all the data that is being collected and should be collected or needs to be collected. Each of these area topics, especially in the types of data that need to be collected, could have their own hour-long lectures as well. So when we talk about why are PFAS data necessary to collect, so there's kind of three things I think about: is the scale of the challenge, the complexity of the challenge, and the conservation strategies that the data informs. So PFAS itself has been used for decades. So there's multitude of products that PFAS compounds are in, and has been around for a long time. So when we think about the scale of challenge, there's things that we know. So there's known contaminated sites across the country that have been tested with a wide range of concentration levels present at these sites. A lot of these are typical, like groundwater, soil, surface water concentrations. But then there's also, what do we predict? So what are the presumptive contaminated sites that could still be out there? And these usually are predicted based on the industrial areas that are in these locations. So you look at industrial facilities, wastewater treatment plants that would be producing biosolids and sludge, military sites and major airports that might be using AFFF firefighting foam for putting out fires, as well as training purposes, which can cause environmental contamination as well. So when we think about that scale of challenge across the US, these presumptive sites become a lot of different locations, many in agricultural areas, which could impact agricultural ecosystem. So then when we think about, okay, well, what is the impact in ag? We look at this generalized PFAS cycle. So the general PFAS movement through the environment and agricultural systems. So you have an input from industry that could be groundwater release, but also agricultural land release, release into wastewater treatment plant that could also be released into biosolids then. And all these can impact agricultural land. So you have ground and surface water inputs, not just on the soil, but to the animals themselves. You also have biosolid application, but you can also have industrial waste applications such as paper pulp. And all this affects crops and food animals. But reality is much more complex than that. We have these feedback cycles that continue because you could have animal waste that's contaminated that's put back on soil. You could have water that's continually contaminated because of runoff from soil. And then you have movement into crops or feed for animals that then contaminate animals, but they could also be receiving contaminated water. And we saw this a little bit when we dealt with the situation in New Mexico at the large dairy that was by an Air Force base when they had groundwater contaminated with AFFF. Not only were the animals contaminated from the groundwater, but they used that water for irrigation of feed crops that also then contaminate animals. So you have this feedback loop. So it's a very complex challenge to consider, and all the inputs and outputs that you have to consider are also important. So then when we start thinking about, okay, how can we limit, how can we do have strategies for soil conservation? So when the PFAS data needs for developing conservation strategies throughout this whole cycle, you want to look at the data needs for soil amendment. So what are the concentrations from the biosolids or manure being put on soil at? How does it affect soil quality? Does it affect the nutrients? Does it affect the organic matter? What about water quality? Mitigation and remediation efforts for soil, water, animals. And then what about waste management? Because animal waste, especially in beef production or dairy production, is a huge issue. So if you have animal waste that's contaminated, we need conservation strategies for that as well. So then our next question is, well, with all these unknowns, what PFAS data are necessary to collect? So the first and foremost, what is the currents? Where is PFAS found? What are the PFAS levels found there? So how much is in the soil? How much is in the water? Is it being transferred to crops? Is it being transferred to animals? And then what about the feedback? So if it's being transferred to animals, the animal waste that's going on the soil, what are the levels that's in animal waste? What are the levels on the biosolids that's being applied? What about the runoff from the cropland? So all this is needs to be known. And then for specific areas, what is the fate and transport of PFAS compounds in soil? What about crop uptake, animal uptake, waste management? So for specific, and I kind of went over this for the currents of PFAS, but so where are the high levels in agriculture? But what are the specific concentrations in agricultural compartments? So inputs, the sources, soil amendments, environmental contamination. What are the soil levels? What are the known soil levels across the agricultural landscape? What are the water levels, ground and surface water? What is plant uptake? So human crops, or what currently is being provided for human crops and animal feeds? What are the levels in that distribution? Livestock and animal byproducts. What currently are the background levels for these products? And then also what are the levels in agricultural waste? Then when we look at soil fate and transport, now there's a lot of data that probably still needs to be collected, but there also has been a lot of data collected on soil processes and PFAS fate and transport. So when we look at these, we look at sorption and desorption data, absorption and biodegradation data, especially in the case of precursors. What about amendment input? Does this affect soil fate and transport of PFAS compounds? Precipitation and runoff will affect soil concentrations. The soil type and characteristics affects fate and transport. And then also precursor transformation that are maybe to more stable PFAS compounds, which you have changing concentration levels in soil then. And then crop uptake. So what are the data needs? Uptake from different crops, especially human crops and feed crops. Are there different components within these crops that might uptake more than others? So in the case of some plants, we know that the leafy portions have higher concentrations than maybe the fruit portions. What about uptake from different soil types and conditions, arid regions, wet regions? What are the processes that affect uptake? Maybe there's certain processes within the root interaction in the soil that could help with eliminating uptake or decreasing uptake. What about distribution of PFAS to various plant compartments? So how is the commodity or feed affected? So if we can still utilize crops that maybe the edible portion has a lower concentration, might be useful. Processes that affect plant uptake, so transpiration or water availability. What about biotransfer and accumulation factors? And then again, precursor transformation. That's a common theme kind of throughout all this, is that precursor transformation. And then for animal uptake, kind of similar areas. So when we talk about animal uptake, there's kind of a straightforward study that we do called absorption, distribution, excretion, and metabolism, absorption, distribution, metabolism, excretion, or ADME studies. This is where we look at the bioavailability, the disposition into tissues, if there's any metabolism. So this is really important for precursor compounds, and then how much of that compound is excreted. So uptake and viability of PFAS in different livestock species is really important, especially from water and feed inputs, because the bioavailability and absorption can be different. And then we want to look at pharmacokinetic patterns, especially differences between PFAS compounds, because there are some differences in blood concentrations in some of these compounds. What about the distribution into edible tissues versus maybe tissues that aren't put out for consumer consumption? And then distribution of PFAS into animal byproducts, such as milk and eggs, that are available for purchase. And again, transformation of precursor PFAS compounds. And then how much is the PFAS eliminated to waste, which is very important to know for waste management purposes. And then also for all this data that's collected within these ADME studies is also important for comparison to when you start developing mitigation or remediation strategies for animal uptake. So for waste management, data needs. Animal waste, for animal waste include lagoon management, composting, manure spreading, and then if all these are unavailable, it would be landfilling, which could cause leachate concentrations and things like that. And so all these concentrations or how these compounds interact in these different settings is important to know. But then you also have the case of if a farm is contaminated and they end up culling animals, animal carcass waste and product waste is also a consideration when we talk about waste management. So then who uses the PFAS data and how do they use it? So I developed 3 different categories, but this is not by any means all encompassing. There could be other uses for this data, especially for like communication purposes and things like that. But one main category is researchers, and then we also have like state departments of agriculture, environment, and also agricultural extension, and then policymakers. So for researchers, one of the 2 things that typically our data would inform are risk assessments. So this is going to look at for toxicity purposes, and then also developing exposure estimates for consumers and livestock. So these are typically used to inform policy to help set different levels. And then we also, as mentioned before, we use this data to develop mitigation and remediation technologies to look at, okay, the technology we're using, is it decreasing maybe the absorption? Is it increasing the elimination from an animal? Is it maybe it's decreasing the uptake in plants or immobilizing in the soil? Then we have the state departments and agricultural extension. So this is more going to be outward facing, and these data are going to be useful for answering questions for farmers and consumers. They're going to be useful for development of management strategies by departments of ag. And then sampling and data interpretation information is also out there on that the state departments put out. So this is from an agricultural extension in Michigan, but they utilize some of this data for, okay, is sampling important at a farm? So they can provide farmers information on whether to sample or not and things like that. And then last is going to be policymakers. So this side's a little bit more busy. So in the case of NRCS, this data could be used to determine conservation practices as well as management practices, strategies to help with soil quality, soil conservation. And then for other policymakers, we're talking about developing acceptable levels for food commodities. So we talk about raw and processed products, aquaculture, and organic products. And when I say acceptable levels, this could be tolerance levels, action levels, maximum residue levels, quality standards, action guidelines, even consumption advisories in the case of wildlife and fish. And then also they're going to be utilized in developing acceptable levels for agricultural practices and matrices. So in this case, it could be those risk and exposure assessments would be helpful in determining kind of the transfer from different matrices. So we look at, okay, if you want an N level in a certain product, you can work your way back and determine what levels do the biosolids, soils, water, and feed need to be below to make sure we stick below those levels in the commodities that are set. And I know it's an abrupt ending, but that's kind of all I had. Obviously, a lot of those categories we can go into far more detail on. So I hope that at least as a beginning in what kind of data, and a lot of this data has not a lot of it, but some data has been collected in each of these categories already, but far more still needs to be done.
Great. Thank you, Sarah. That was fantastic. Are there any questions from the committee? Jennifer.
Yeah, hi Sarah. Thank you for that presentation. Just a quick follow-up to that last comment you made about data availability. So I guess could you elaborate on that a little more as far as if there are any primary data sets that you would look to, for example, for data in, waste at PFAS concentrations and waste at impacted facilities. I know there's a lot of biosolids data out there already. But are there any other primary data sets that you might look to that might be sort of more off the radar?
Not obviously if you're looking at like food commodities and things like that, FDA has done their total diet study. We conduct the research that we conducted our laboratory. We're starting to produce data sets for different livestock species. So we've already done quite a bit of work on beef cattle and dairy cows. We're doing work in poultry right now. And then I would say looking to states that are conducting occurrence studies. So where they're looking at waterways and soils maybe, and then fish. Wild caught fish is another one that I know like state of Maine has been doing. So those data sets are maybe a little or not as accessible as what's out in literature. And then also the USGS has been conducting quite a bit of occurrence data if you're looking at how widespread the issue is. As far as like the soil fate and transport, crop uptake, that's all going to be found in literature, peer-reviewed journals. But I do know there, as Dr. Knabel mentioned yesterday, there are it is in the works to kind of centralize data collection and to find data that people need to do maybe their modeling work or their risk assessment work. And so that kind of procedural activity is underway to kind of have a centralized database for finding that data because it can be spread out amongst different categories. So I hope that answers your question.
Yes, thank you.
I can chime in a little bit. So there's an organization called Interstate Technology and Regulatory Council. Yep. Okay.
Yep.
Yeah, you can find some data. It's not very extensive, but it's a great starting point for what crop and crop uptake data.
Mhm.
Sarah, there's a question in the chat about can you say anything about the specific PFAS compounds you're studying?
Sure. So our research mainly has focused on the carboxylic acids or the perfluorinated carboxylic acids and the perfluorinated sulfonates. So we're from 4-carbon chain length all the way up to 18-carbon chain length in the case of our longest compound. And what we do notice, I'm going to speak to poultry because we haven't done all these compounds in the realm of beef and dairy cows, but we have done a little bit. But for poultry, we see that typically after about 10-carbon chain length, we don't see a lot of accumulation in poultry. We have all the plasma detection limits, or the plasma detection for anything longer than 10 carbons is typically below the detection limit. And then the 6-carbon chain length to 10-carbon chain length is really where we see accumulation in the plasma of poultry and liver of poultry. As far as dairy cows, when we did the New Mexico dairy study, and the New Mexico dairy study is all published, we saw that we didn't see accumulation of the carboxylic acids in the dairy animals, but we did see accumulation of the hexa, hepta, and octasulfonates, as well as 2 branched isomers for the octasulfonate or PFAS. And so that information is all published and out there, and that was a cohort of about 160 animals. So a good population kind of study with lifetime exposures.
No, thank you.
And if anyone needs more specific information, they can look to those published manuscripts.
Any other questions from the committee or anyone else online? Sarah, I have a couple questions. I really enjoyed your talk, and I think about the complexity of this issue in the environment, and I think about some of the images you shared with us about where PFAS compounds are known to be, and then the predicted areas where PFAS compounds may be. And I think about just how widespread this is, and where where should we focus our efforts in terms of studying, just like from a soils perspective, where should we go? Everywhere? Nowhere? I just think about the point and non-point source pollution issues with PFASs, and where where should we be maybe focusing our efforts, but then also taking a look at places where, yeah, maybe we might not find PFASs, but maybe we should just poke around and see.
Yeah, and I think that leads back to, and David might mention this a little bit in his talk too, so I don't want to speak too much on it. We need goals, I think, is especially in the terms of what do we want soil levels to be under? What do we want biosolid levels to be under to still be utilized as maybe a soil amendment? What are acceptable levels in some of these agricultural matrices? And so we always look to this known contaminated site, and then you see these different levels of contamination. So you have sites, lots of sites that are 0 to 10 parts per trillion. Are those as important as maybe some of these sites that are over 100,000 parts per trillion? And where do we focus our efforts in that case? Because obviously this is an exhaustive list of sites that still need to be tested, as well as all the matrices involved in those sites. And I think that I think we need some goals in that case. Like, do we want to just focus on the more contaminated sites? Are those going to be in areas that are agriculturally important to start with? And then but you also have like watershed considerations and things like that. So are there sites that maybe feed into agricultural areas but aren't necessarily nearby agricultural areas? I think that, but the goal, I think setting goals of what are acceptable levels in these agricultural matrices, soil, biosolids, waste, and then having something to work towards. So if you have sites, maybe those 0 to 10 sites aren't as necessary to focus on as the more contaminated sites, if that helps.
That's helpful. I do have another question based on some items that you touched on about animal products and where PFASs may end up. And this is not my area of expertise, but I do think about animal products and maybe products that people don't normally think about that may be utilized in agriculture, like bone meal, for example. And I can't remember if it was Clinton or one of the other ARS scientists that were talking. I think it was Clinton who was talking about where PFASs may end up in animal tissues. He was talking about this yesterday. And of course, bone was one of those locations where some PFAS compounds end up. And I just wonder about what we should be concerned about. Like in terms of animal products, really, where should our concern be? Should it be everywhere or?
So in our case, when we did our first initial studies back in 2010 in beef cattle, now these aren't chronic exposures or anything. These are single exposures, but high level. When we looked at the distribution in different tissues, the two main tissues that we found, or compartments, we'll call them compartments because plasma is not technically a tissue, but plasma and liver were the two high ones. Then when we went to muscle, so your main edible tissue from beef cattle, muscle is about a tenth of what plasma and liver are. So when you so we could consider, like, if you do have contaminated animals, something to consider is maybe discard of offal. So you discard that liver, that it doesn't get it out into consumer hands. But the muscle might still be okay. That's another reason why action levels might be important in this case, because we don't know, or we can't give guidance on anything that we can say, well, okay, your tissue, your muscle levels on your farm are, let's say, 2 parts per billion, but we don't, in the grand scheme of things, without action levels, we don't know what that means. Do you need to consider culling all your animals? Are they okay to go to market with certain not discrepance, but certain rules or exceptions? But we can say, like, for edible tissue in beef cattle, muscle typically, and this is pretty well known, we've done a lot, there's been a lot of different studies, not just our lab, but worldwide, that have looked at the correlation between plasma levels and muscle levels, and it holds pretty well through different exposure rates, different concentrations that are present, that plasma to muscle ratio is about 10 to 1. So plasma is typically 10 times higher than muscle. Liver is kind of in that same realm. Liver is the next, behind plasma, liver is the highest tissue level that's present. And we've been finding that in chicken and poultry as well. So
Interesting. Thank you. Any other questions? All right. Thank you, Sarah. Our next presenter is Dr. David Smith. Dr. Smith is a supervisory research physiologist, also based at the Schaefer Agricultural Research Center in Fargo, North Dakota. His research focuses on the absorption, distribution, and deposition of PFAS residues in food animals, for which few data exist, and on determining the fate of PFAS during carcass composting. He also investigates the absorption, distribution, metabolism, and excretion of emerging and legacy chemicals in food animals, and he develops and validates sensitive and accurate rapid analytical tools to detect emerging and legacy residues in food animals and food animal systems. Dr. Smith, we look forward to your presentation.
Okay, thank you, Dr. Ippolito. Can everybody hear me, and can you see my slides?
Yes and yes.
Okay, great. Thank you. Again, thanks for the kind introduction, and thank you for the invitation to speak to you all today. That didn't advance, did it? Let me try this one. Okay, there we go. So I'm the research leader of the Food Animal Metabolism Research Unit in beautiful Fargo, North Dakota. The mission of our lab is to investigate the fate of chemicals in food animals and food animal systems. We broadly define that set of chemicals that we study, but today I'm going to be talking about the perfluoroalkyl substances. And I was asked to discuss solutions to mitigate the impacts of PFAS contamination on agriculture and food and agricultural food systems. So when I saw this topic, I thought, well, okay, well, what is an agriculture? What is a food system? What are we talking about? And so I like to think of this very kind of broadly in terms of the ag ecosystem. The ag ecosystem is really everything that contributes to food production for humans. So that includes water, soils. It includes inputs into soils like perhaps biosolids, composts. It includes the crops that are grown for animal feeds, and then and human foods, and also the residues that may go back into the soils. It includes the animal products that are going to be consumed, that are targets of, for example, production, and then again the wastes of those animals. So, in terms of food systems, I don't want to lose sight of the fact that in human food, which is part of the ag ecosystem as a whole, human foods and animal products, whether they're plants or animal products, they're also processed. So processing is part of this continuum as well. And processing in the cases of PFAS may be a part of the solution as well. And I'll talk about that just a little bit, but not a lot. So I want to, I've got lots of siblings in my family, and they like to point out that I had a pretty good grasp of the obvious about 50% of the time. And so I did want to point out that in terms of mitigation, if you can isolate point sources that are contaminated with PFAS and not use them in animal production or crop production or in soil amendment or whatever, that solves the problem, right? That's kind of obvious, but I think it needs to be said, and I think it addresses the question that Dr. Ippolito had maybe a little earlier. Even for industrial sources or industrial contamination sites, if you can isolate those point sources and treat them, that'll solve a lot of problems and prevent a lot of problems down the road. So I did want to point that out. The problem with PFAS is that that these are legacy chemicals. They've been in production for nearly 80 years. The cat's kind of out of the bag, as we've alluded to earlier today, and as Sarah's graphics have shown. So there's a lot of contamination out there, and there's a lot of contamination of different sectors, if you will, of this ag ecosystem, and they all interact and they all impact each other. So the cat's coming out of the bag. If we find a contaminated portion of the ag ecosystem, then the question is, can we mediate that contamination? And I want to reemphasize some of the discussion that we've already had that Sarah mentioned, is that unless you have a target for remediation in terms of what I'm going to broadly call safe or what's acceptable, then remediation doesn't have a lot of meaning in the context of our ability to measure PFASs. And I just want to give you an example of this. All right, so this slide basically summarizes Food Safety and Inspection Service data from 2020 to 2022, in which they looked at nearly 2,000 bovine muscle samples from cattle slaughtered across the United States. The detection rate for PFAS at a limit of quantitation of 0.5 parts per billion was about 0.1%. They found very, very, very few animals. And that's a good thing. I mean, that's a really good thing. However, this study by Mikola Quits, sorry if I butchered that name, but this study that came out of Poland in 2024 basically had a detection limit or a quantitation limit that was 50 times lower than what the US FSIS used in their initial survey. They looked at bovine and pork muscle with a fairly modest number of samples, and they detected their detection rates were significantly greater than what the USDA found. And of course, with a lower detection limit, that's probably to be expected. And so Sarah mentioned that if you select the matrix, though, a different matrix, and use maybe even a higher quantitation limit, in this case, Zhu and Murphy, and it published this in 2024, they looked at bovine, ovine, goat, and horse serum samples, and their detection rates were, for about 73 to 100%. So the question then becomes, well, what do we do with these data? What do these cattle where we detect something in the serum, do those need to be quarantined? Do those animals, do those carcasses need to be condemned? That's why I want to reemphasize that before we start mitigating things, we've got to have action limits, and action limits are enter into the policy realm, and so we can provide data to inform that, but it's a fundamental question that has to be talked about hand in hand when we talk about mitigation. And the data on the left, the graphic just shows that the slope of the plasma to muscle concentration curve is about 10, like Sarah mentioned. Okay, so then what strategies do we have for remediation and management across the ecosystem. I'll start with the two PFAS sources that might be considered point sources in most cases. That's surface water and groundwater. There are some mitigation options for water, and most of these have been developed for human, developed in research primarily for human exposures, or reducing human exposures, or use at wastewater treatment plants or water treatment plants. They fall into two broad categories. There's physical mitigation techniques, which include nanofiltration, which is exactly what it sounds like. It's nanofiltration. You use higher pressures and you push water through with a nanofilter, and if the pore size is small enough, you can retain PFASs. Reverse osmosis. There's absorption technologies, which include ion exchange, activated carbon, biochar, and what I'm going to call proprietary sorbents or design sorbents that are being produced specifically for PFASs. And then other physical techniques include foam fractionations and ozone fractionations, which are kind of the same technique. One uses inert gases like nitrogen in nano-sized bubbles, and it takes advantage of the surfactant properties of PFASs so that you form a foam that you could scrape off. Ozone uses, it's the same thing with ozone, except you're providing a strong oxidant, so you get maybe a little breakdown along with the separation. Okay, so with physical separation, with the physical techniques, the problem is that you still have the PFASs. Now, they are away from the water product, and you do have you've lowered the concentration in the water, so you've mitigated, but you still have the PFASs you have to deal with. They're not destroyed. So the chemical techniques are really have been developed in research with the goal of destroying the PFASs. Photolysis is pretty inefficient, even with UV light. It does work in some cases, but it doesn't work well. If you add an oxidant during photolysis, you get a little better rates of destruction. Those oxidants are typically chemical oxidants. And then with photocatalytic oxidation, you've basically used light, oxidation, and you throw in a catalyst to help increase the rates of defluorination or PFAS breakage. Activated persulfate oxidation is another technique that relies primarily on chemical techniques. Persulfate is a very strong oxidant, and if you dink around with the system, I know that's not very scientific, but the persulfate oxidation can be modified using catalyst and also other techniques. So there's other techniques sort of in this destructive mode, sub and supercritical water, electrochemical oxidation, which works actually pretty well, but it's very, very expensive. It used a boron dope diamond anode, and electron beam is basically another technique that uses high energy to destroy the PFASs, and people have also investigated the use of plasma gases, ionized gases in water systems. So in total, the problem with water mitigation techniques for agriculture is that most of these systems are not amenable to agricultural situations. Some big players might be able to afford these types of systems. I'm talking about the ADMs, the Cargills, for specific locations that they might be impacted in, but for the everyday farmer, it's just not going to happen. Okay, so what about biosolids? There's not really a lot of options for if there's contaminated biosolids. I think the state of Maine is now landfilling any contaminated biosolids. There's some problems with that because it's not only expensive, but it fills up landfills much quicker than would otherwise be they'd otherwise be filled. And the physical techniques also are incineration, hydrothermal liquefaction, and some people indicated that pyrolysis, if you make biochar out of these contaminated biosolids, you might be able to bind the PFASs in those as well. I've got underlined here, some biosolids might be applied to land in limited quantities that are not necessarily involved in direct agricultural applications. Selective land applications, for example, if you had a biosolid that was that contained primarily carboxylic acids, you might be able to apply that to a land in which cattle are grazing, because cattle don't accumulate PFAS and those carboxylic acids. So these things are possible, but they're certainly not. We're not at the state where it's occurring on a widespread basis in agriculture. So for soils, a highly contaminated soil, for example, maybe at an industrial site, might be landfilled, but that's just an option. For soil remediation, physical techniques include those techniques which are used for other types of remediation, or remediating other types of chemical contaminants. That include washing with solvent, incineration, smoldering, which is a lower temperature. It's not really combustion, it's not really pyrolysis, but it's a lower temperature heat treatment with some fuels that you could do, and there's been some destruction of PFAS using that technique, and also mechanochemical, which is ball milling. I don't know a lot about this other than it has been shown to work partially, but not extensively. I'll put it that way. So for soil remediation on an agricultural scale, really you're talking about adsorption, perhaps with biochars. I know that's being investigated pretty widely now. A lot of different biochars are being studied. Bioremediation, Jude talked about yesterday, we're not ready with that yet, but that's a possibility. And also phytoremediation, which I'll talk about a little bit in a coming slide, may also be a possibility. But there's nothing really right now that we can, if we've got a contaminated site, that we can just go say, well, we're going to remediate the soil. And I want to, again, with the caveat that would be on it sort of in the agricultural setting. Okay, so what about a crop? What if you've got a plant that's contaminated? What can you do with that? Well, really, you can't do a lot. You can put it in the landfill. Typically, you're not going to feed it to animals if you know it's contaminated, unless it's contaminated only with carboxylic acids. Then you might give it to cattle. But if I was a cattle producer, I'm not sure I'd want that just for marketing. Okay, so then also, Sarah mentioned this a little bit. You might be able to mitigate the contamination through processing. So, for example, if we know that grains typically don't accumulate very much PFASs, but if you process that grain and one of the grain fractions contain most of the PFAS, maybe you could use the other fractions for some type of food. I think that one thing that we'll see in the future is the development by plant breeders of hyperaccumulating plants, which I've kind of showed in the bottom left. If you had a plant that could hyperaccumulate PFASs, then that might be a way to remediate the soil, and then you could use perhaps the plant mass to incinerate for energy purposes, and then of course you'd have to capture any short chain PFASs that would volatilize, and then you'd also you'd have to collect the ash. The ash would be a waste product. There also might be opportunities to develop plants through breeding that are selective accumulators. And what I mean by that is, I've got this shown. If the plant would only accumulate PFASs in a non-usable part of the plant, then you could use the non-accumulating portion perhaps for productive purposes. And although I show this in the stem, you can think also of a selective accumulator as maybe also in the roots, so that you could use the top portion of the plant versus the underground portion. Now, that doesn't do anything to to help the soil, but at least you could use the land for productive purposes. Okay, so then the next thing a plant breeder might be able to do is to develop maybe a hypo accumulator in which the plant doesn't accumulate PFASs at all, and then you could use land productively. Okay, so what about livestock? Livestock are the obvious thing is you've got a contaminated beef or chicken or animal is going to go into the food chain. You could use depuration, which is basically you give them clean food and water, and you let the PFASs just eliminate naturally. The problem is that the half-lives for most of the PFASs exceed the economic production cycle for most species. So, for example, our data here shows the PFASs removed from cattle from a contaminated dairy farm in New Mexico. After 22 weeks of depuration, the summation of the PFASs, both in heifers and matured cattle, were, and this is in plasma, but they were still very, very high. You might be able to use management techniques, for example, selective grazing during a depuration period for young animals that were exposed, or restricted feeding. One thing that's being investigated pretty widespreadly now for people doing this is the use of sorbents or binders in the feed. Those sorbents and or binders would include biochars, PFAS selective proprietary sorbents. Cholestyramine has been one that's been used for a long time. I don't know that would be used commercially just because of the expense, but it's certainly used in experiments to show as a positive control because it's known to bind PFASs. Okay, then there's some natural products being studied. Is it possible to use to remediate animals using a feed additive? I'm just going to show, this is my last slide. Well, my next to last slide, and I just want to show some work that is not published. We've done this here in Fargo, looking at a proprietary sorbent. We fed chickens. We gave chickens lifetime exposures with 11 dietary PFASs, 11 PFASs in drinking water. These were at environmentally relevant concentrations, 100 part per trillion in each. And then we looked at this silica-based sorbent at 4 different levels in the diet. The sorbents were at part per million levels in the diet. We exposed the animals from basically hatch to slaughter at 6 weeks, and there was no zero withdrawal time. So if you look at the plasma, all I want to show here is that there was a declining trend for PFAS accumulation. Now, these are sulfonate accumulation in the plasma of these animals with sorbent level. This was our initial study. We had no idea about dosing, so this was really a shot in the dark. It was a guess. And so the horizontal line at the bottom of the graph is the scale of the same data for muscle. So our plasma data is kind of the worst case scenario. These concentrations are in the sub-nanogram, or excuse me, in the nanogram per mil range for plasma. For meat, it was in the sub-nanogram per mil range. And so we think with further development, these sorbents perhaps could be used for livestock. Okay, so I've probably talked longer than I should. So what's the conclusions? So remediation of highly contaminated point sources will have long-term impacts. I thought I should include that because, again, because of the PFAS cycle and the distribution, and because of the sensitivity which we can measure these, those highly contaminated point sources should be addressed. Okay, so there needs to be a lot more research. Sarah alluded to this. There needs to be more research on remediation and/or conservation tools for most agricultural matrices. No single remediation technology really exists, which is suitable for agricultural enterprises. Naturally accepted action limits have not been established for most matrices, and they're sorely needed because remediation targets for specific matrices will really be driven by those action limits. And that's all I've got.
Great. Thank you, Dr. Smith. Any questions from the committee or others online? While we're waiting for those to come in, David, I have a couple questions for you. So specifically, first of all, I have a comment. So I like what both you and Sarah pointed out in terms of point sources and potentially isolating point sources. And so part of my job, I do work with biosolids land application, and I know the wastewater treatment plants, they're doing something identical to what they used to do when we had point source pollution with heavy metals or trace elements. And so they're finding those point sources upstream from the wastewater treatment plants, and they're starting to eliminate those or attempting to eliminate those in this case for PFAS. So I'm glad you pointed that out. Why don't I ask you a couple questions, and then I see Tom, you have your hand up. Let me ask these first. These perfluoroalkyl carboxylic acids, these PFCAs, do you ever find those just by themselves in the environment?
Yeah, no, not that I know of. Not that I know of. Sarah might be able to have a better idea of that, but not that I know of, no.
What about like why do they just pass right through the cattle, right through the rumen?
So I think that the issue is is a binding protein actually at the kidney. I think cattle are able to efficiently excrete it. So Sarah did a study, well, probably one of the first studies she did while as a postdoc here, and essentially we gave a radio-labeled perfluorocarboxylic acid, and it was essentially 100% excreted. We got complete recovery in the urine. Wasn't it the urine, Sarah?
Yeah, that's right.
Yeah.
I think within a week of
Yeah,
dosing.
7 days. So, so the only comment that I would want to say is you ask about, are there any places where you find only perfluorocarboxylic acids? And the answer is no, not from an industrial contamination point of view, but there might be places where there's potential for enrichment of perfluorocarboxylic acids because they're not being accumulated by cattle. I mean, that dairy in New Mexico, that might be interesting to look at that soil because those were lifetime exposures, and that place had been exposed for decades, is my understanding.
So I'll just add to David's comment about the kidney. So this has been seen, I believe, in mice and rats as well. And this is alluded to in sex differences. So between female and male, intact males specifically, that you have testosterone, the increased incidence of testosterone in the male sex has, you get production of what we call the OAT, or the organic anion transport proteins, which cause the carboxylic acids to recirculate back into the bloodstream. And in females, and then also castrated males, you don't observe that because you don't have the testosterone levels to produce the OAT proteins and enzymes that would help with that recirculation in the body. And so the reason we picked up on this is because when we did that initial study, we used steers, so castrated male cattle. And then in our next study, we use steers and females and saw similar data. And so, but we haven't looked at bulls, so that might be a different. So they might accumulate carboxylic acids just because they still have that testosterone concentration in their system, or a higher testosterone concentration in their system, that would allow for that recirculation of the carboxylic acids rather than elimination through urine.
Fascinating. Thank you. Tom, let's go to Tom Christensen for a question.
Thank you, Jim, and thank you, Dr. Smith. Yeah, I'm a committee member. I actually spent 40 years with USDA, most of that with NRCS. So I kind of come at this question from an NRCS perspective, because ultimately they have to use the information for conservation practice standards, conservation planning, and then using the financial assistance to apply those. Great presentations over the last 2 days from ARS. But I don't think I've really heard anything specific where there's this engagement between NRCS and ARS on particular practices and the effects of those practices on mitigation. A couple come to mind, you kind of alluded to them. There's a fairly new soil carbon amendment practice standard. There's the feed management practice standard, which came on about 20 years ago in NRCS. And I'm wondering, just to try to gauge my level of understanding, has NRCS yet approached ARS specifically and said, we have these suite of practices, we think they may have some usefulness in this area. We'd like ARS to look more at the effectiveness of those practices. And I'll draw a parallel. If you're familiar with water management, drainage water management, bioreactors, saturated buffers, plethora of research across ARS, NIFA, that gets more at the effects of those practices. That's been going on for decades. I don't sense that's here. Maybe it's because the science is not yet at that stage, but really my basic question is what kind of engagement is taking place between the two agencies? And has NRCS asked you specific questions about the effectiveness of conservation practices in this arena?
Yeah, so we have been engaged with NRCS. Clinton, I don't know if you're raising, and David, if you're raising your hand to address this question, but we are engaged with them. We're not really to the point, at least on the animal side, where I've been most engaged to take conservation practices to the field, because we just don't know. I mean, we don't know what will work, what won't work. I know that we're actively engaged with okay, so when I say we, our group that's looking primarily at that fairly narrow ag ecosystem of food animals, we're engaged with biochar producers, we're engaged with companies that have proprietary sorbents, those types of things. So those are just being developed. So it's not really a place where we could take that to. Now, some of the sorbents and some of the biochars may have actually fairly wide application across the ecosystems, but we're not there yet. Clint, or do you have anything that you could add to that?
Yeah, I was just going to add that one of the things that we've started with is we're currently conducting a quantitative literature review to look for all PFAS, anything PFAS in the ag ecosystems. And then from that, we'll mine out whatever we can find, because that's kind of the first step, is what's out there being proposed. Once we know those things, what have shown promise, what maybe haven't, then we can start working down that path of what practices are helping. And NRCS helped to pay for that. It's helping to pay for that quantitative literature review. So once that's completed, then we'll have more of an idea of what steps we can take to help NRCS know what their conservation practices we should actually evaluate.
I was going to add too. Thanks, Clinton and David. We have been engaging with NRCS through Nolan Herbert leads a group. He has different segments of FPAC and NRCS working on the PFAS problem. And we were invited, many of the folks in this room, to attend those to inform them about what we're doing research-wise. And then, as Clinton said, they've been very helpful with getting us resources we need. One of the challenges with the research that's needed for the practices is we don't really want to intentionally contaminate land where we would implement a practice large scale. There are some farms being purchased in the state of Maine that have PFAS contamination, and some of those will be used for research, so that might be an opportunity. There may be some others available already have the contamination where we could do some replicated experiments. And then there's also the confounder of regional differences, climate differences, rainfall amounts, soil types that may affect the behavior of PFAS, and then does a particular conservation practice that has beneficial effects for, let's say, immobilizing PFAS and rendering it non-bioavailable for crop plants in a nearby field, or does it do something different? So it's, I would say we've had those conversations, but trying to find out where to implement those studies. I mean, we can do greenhouse studies, but again, getting them to the field, there's some challenges with that. So, but very interested in, one of the groups we're working with is very interested in data, so locations of contaminated areas, and then trying to work within states or other agencies to see if there's opportunities to have those be research sites, have those be purchased. So a lot of moving parts. Thanks. I hope that helps a little bit.
Yeah, it does. Thank you. I was going to comment too, they have the Conservation Innovation Grants you might be familiar with.
Right.
Not a research program per se, but could be used potentially in some of those
Right.
sites you mentioned to look
Right.
at practices and the effects.
Right. Thank you.
I'll just also add that NRCS, along with Clinton Williams, they have their sampling egg land sampling program for soil sampling as well, and that's a collaboration between NRCS and Clinton's lab.
Thank you.
Any other questions, comments? Okay. Oh, there's a question in the chat. The question states, they mentioned, that means both, I'm assuming David and Sarah, you mentioned goals or target levels. Do you have any sense of which PFAS compounds might be important to develop targets for, or is it still just too early?
Yeah, so I'll address that. So target levels, action limits are typically set for compounds that have the greatest toxicological database. And right now, across most action limits that I've seen globally, they're PFOA, PFOS. Sometimes it's the hexa, and Sarah, I'm missing one.
PFBA.
Yeah, PFBA. The kinetics of those in humans and animals are a lot different, so that the target levels can be different. A lot of times they're set as the sum of all four of them. So typically, that's what they're set for. I will say that the target levels vary a great deal within the United States, across states. Most states don't have action limits. The federal government doesn't have action limits yet, although they're developing them, except for drinking water. In Europe, there was a paper that's published just very recently that was illustrated the difficulty with setting action limits across different regulatory groups, because they use different assumptions in those things. So the regulatory aspect is complex, and it's not straightforward in itself, but it has great impacts on what we're doing, because that's where action levels and advisory levels come from. I would say, and I would give compliments to the state of Maine. They've done a very difficult job. They've probably, I think in the United States, maybe Michigan too, Sarah, but they've done probably a better job of saying, okay, this is what our goal is, and setting those. But again, one of the things that I didn't say, which I probably should have, is that none of the remediation techniques are universal across the vast number of PFAS compounds. In other words, some are very, very good at removing long chain PFASs. Others are very good at removing short chain chain PFASs, but almost none of them are good at removing everything or destroying everything. So that also further complicates the idea of these action limits. So I may have wandered off of the question, and so if I didn't answer your question, let me know.
I think you mostly answered it.
Okay.
Yeah, to develop targets for specific or a broad range of PFASs, whichever you
Yeah.
think
So
is
there, I don't know if the questioner is familiar with the dioxin regulatory world, but dioxins are regulated as a class based on toxic equivalency factors, and there's been some attempts to do the same thing with PFASs, in which you basically index the toxicity of a given PFAS against the one known to be the most toxic. I would guess, given the number of PFASs that are out there, that as we move forward in the next decade to decades, that there'll be some type of index system. But
Yeah, and
again,
that
that's for regulatory people to decide.
yeah, and that I think EPA has tried to do that with their hazard quotient, which is not necessarily a toxic equivalency factor, but it's a summation of multiple compounds rather than each individual compound having its own action level. I'll just add in the case of Maine, they have developed I think it's soil action levels and then beef and milk action levels just for the state of Maine. And then Michigan, I believe, has a biosolid action level as well that's been developed. And those are based on previous like risk assessments that have been conducted.
perfect. Thank you. Any further questions or comments? Okay, seeing none. Thank you, Sarah and David, for speaking to us today, and thanks to all of our ARS presenters from today as well as yesterday. As of now, the committee plans to meet again on April 3rd, 2025. More information about that meeting and other webinars will be posted on the study's website when details are available. You can subscribe to the board on agriculture and natural resources to receive notices about newly scheduled meetings. And thank you again for everyone attending today's session.